So we've done a pretty good job getting a lot of decisions out there in Java. Now we're going to take a look at logic, because that's really what we're doing with decisions. Is we're trying to describe the logic of the program, or what we're modeling, to the computer. So just a quick crash course in logic. All logical statements have two possible values, true or false. There's several operators that we could use. The most common ones that you're going to see in our class is or, and not. And we'll talk about exactly what they mean in a minute. But another common logical operator that programmers use is exclusive or, which that means only one of two things can be true. Both cannot be true at the same time. But the focus for us is mostly going to be on or, and not today, and I will show you how this translates to Java. So when we look at a statement and we use or, we mean that one of them has to be true in order for the whole thing to be true. So horses have tails, that's a true statement. Fish, however, do not have fur. But together, because I'm using the or statement, I only need one of them to be true to make the whole thing true. Okay? I could also use a statement like dogs can fly or birds can fly. This time, dogs can fly is false, and birds can fly is true. Now with an or statement, false or true, because one of them is true, that again is going to make the whole thing equal to true. Fish can swim or cats meow. Of course, we could have both true. You don't need all of the statements to be true, but true or true would give a true statement as well. So the only time you're going to run into a false statement, if you're using the or operator, is if both are false. So pigs can't fly, horses don't have tails. So false or false will give me a false statement. So that's the only time it's going to turn out to be false, is both have evaluated to false. So this time we'll take a look at using the AND operator. And is true when all of the statements are true. So here, horses do have tails, but fish do not have fur. So this will be a false statement with the AND operator, because together they don't make up a true statement. One of them is false. Same problem happens here, false and true. Both of them would have to be true in order to make this whole thing equal a true statement. So when fish can swim and cats meow, both of those are true, so together they will make a true statement. Pigs can fly and horses can fly. Well, both again are false, so false and false will still end up being a false result. The only time that and is true is when both of them are true. Every other time it's going to evaluate to false. So not is an operator that flips the logical statement. So true becomes false and false becomes true. Not can be very convenient. For example, if we wanted to describe an odd number, one way is you could say it ends in 1 or 3 or 5 or 7 or 9. But it's a lot easier just to say it's not divisible by 2. So if we had to code this in Java, this would definitely be your first choice, because it's much simpler to describe. So now let's take those operators and we're going to start putting them together. So the precedence, it works just like math. So they are evaluated from left to right, where and has a higher precedence than or, and not even has the highest precedence of them all. So we'll practice a couple just so you can see. But if we were to look at this, then the and is done first because it has the higher precedence when we go, and then the or would be done second. So the result of this would be, if I evaluate the and, I get a true, and dogs cannot fly, so false or true, the end result would be a true statement here. Now one trick you can do is, because it's kind of like math, which you're probably more comfortable with since Java is brand new to you, is if you want to decide the order, replace them ors with pluses and ands with multiplication. So something like this would be switched to that, so you know that multiplication happens first and or would happen second in this example. Okay, so if we practice a compound statement, then in this case they're the same operator, so they will happen from left to right. So the first thing is going to be dogs fly or pigs meow. That's false or false. So if both are false, the or statement is going to give me a false. Turtles have shells. That is true. So this will be false or true, the result of which is going to become true. So again, this time we have and, which is the same operator. So I go from left to right. dogs bark, pigs oink, those are both true. So true and true, that'll evaluate to true. Then the cats meow, that is true as well. So true and true will give me a true statement when I'm done. This time there's two different operators, and it just so happens that the and is first, but that has the highest precedence even if the order were switched. So and is going to come first, pigs fly, that's false, and dogs don't meow, that's false. So the result here is a false statement. Then I'm going to apply the or operator. So ducks quack is true, false or true, that's a true statement. So overall, this one would be a true statement. So parentheses can still be used in order to change the order that you evaluate, just like you do in math. So for example, 5 times 6 plus 3, I just put a set of brackets in here if I want the addition to happen first. So we can do the same thing if we were looking at a logical statement. Dogs bark or pigs fly and fish run. This is a true statement if we go and evaluate the whole thing. And it's here is what's going to be evaluated first. But if I wanted to evaluate this operator first, then I'll put a set of brackets around it. Now I will use this or operator first, and the result is a false statement. So it is possible to change the order just like you do in math. So you can practice some more of the logic stuff there in the slides on your own, but we're going to jump into the Java now. And typically in the programs that we're going to run, you know, the more that you understand logic, the more flexibility you have in your program. But it's certainly not going to be the deciding factor in whether or not you're a good programmer with this class. So taking a look at the operators and transferring them to Java, this is what you have is and in Java is the double ampersand, or is a double bar, and not is the exclamation mark. And you have to be very careful because these mean something else in Java. And or, they actually mean a binary operator, which if you go on into some more computer science, you're going to find that they have a very good use as well, but not one that we're going to be able to apply to this course. So a super common error, because Java may or may not give you a problem depending on the data types, if you use those as a mistake for the ones that you really mean. So just these ones here, double and, double or, and exclamation mark, those are the ones that we will be using in our course. So for example, if we wanted to describe a teenager as someone between 13 and 19, then we would say that they're greater than or equal to 13 and less than or equal to 19. So if you just heard the way I said it in English, sorry about that, if you just heard the way I said it in English, it was greater than or equal to 13 and less than or equal to 19. So the way we talk in English, it lends itself very well to this kind of a programming language as well. So the age is greater than or equal to 13, that's exactly the condition here, and their age is less than or equal to 19. So this is a teenager. The only way you get in here is if your name works in both conditions. So if both of these are true, then you hit this block, and now we can program as though we know that they are a programmer. As a teenager. So one suggestion that is, this is typically the way you would write it in math. You can translate it to Java from here if you split it right at the middle, but you can't do this in Java because Java only takes one condition at a time, and this is actually two conditions in math. It's a shorthand in math for this. So Java, you have to split it with an and, but you see it splits the same way. 13 less than or equal to x less than or equal to 19. The same pieces are here, it's just I have to split it at the middle with the double and, so that way it shows Java exactly what two conditions I'm referring to. So when you hear me use the term compound if statements, those are going to be the ones that we use these logical operators in. And for example, we could tie into the last one we just did. If we wanted someone who's not a teenager, we would put an extra set of brackets in and have the not operator. And that operator is required, the extra set of brackets is required because the order of operations, it would make not happen first, and it would have applied it to this single condition first, then done the rest of the problem. So be careful about your order of operations. It will matter, and especially in this case. However, if I want someone who's not a teenager, the other thing I could say is they're less than 13 years old or they're over 19. So either would work. Generally we want the simplest one. So generally I think you'd prefer to use this here. it uses less operations for Java to find its answer when it tries to evaluate to true or false. Now, these things can start to get fairly big if you're not careful with the way you're doing it. So for example, if I wanted to find someone who's not a teenager and not a senior citizen, so 65 and older, here's the conditions. This is a teenager, this is someone over 65. So if I put them together, I'll have to say and in order to make sure that they're both true at the same time. Someone who's not a teenager and is also not a senior citizen. So it gets to be quite messy, which is why we have a data type in Java for storing these things, and that's the Boolean. So it's named after George Boole. He's the credited with inventing Boolean algebra, and we can rewrite that previous example, make it a lot neater and easier to understand. So for example, if this is how I define a teenager, I can use a Boolean operator, so Boolean teenager, sorry, a Boolean variable, and define it with, it's going to evaluate a statement that will evaluate to true or false. So that's what Boolean variables store, is it stores either true or false. So this just takes care of whether it's a teenager, this takes care of whether it's a senior citizen. Then when I put them together, just use the variables like this, and I have if it's not a teenager and not a senior citizen. So this is much easier to read, the source code. If you had an error, it would be a lot easier to track down trying to look through this code than the stuff that used to be here at the bottom, which is quite a lot for you to see. So one common occurrence that happens is something we refer to as DeMorgans Law. And just to illustrate to you, these are all possible values of true and false that I could apply to two separate statements. So I'm calling this statement X and I'm calling this other statement Y, but it could be like dogs fly and cats meow. Basically these are the statements and I'm representing them with true and false. So if I look at all possible values, these two things end up being the same. I have false and then all trues, false and all trues here. So what we could say is that these two statements are logically equivalent. Doing not X and Y is the same thing as not X or not Y. If we repeat this with not X or Y, then you see we end up with two logically equivalent statements again, where not X or Y is the same as not X and not Y. So DeMorgans Law is something that you're going to end up seeing in code where you wonder, maybe this is the statement you were going to write and you decide to write it down this way because it's going to use less operations to do it. There may be another reason why you prefer it that way, but DeMorgans Law is one that's common enough in programming that we see it as a way of simplifying our code. Now, if you're going to be taking the advanced placement programming course, you should know that being able to manipulate DeMorgans Law is actually a part of the exam as well. So if you recognize the pattern when you have both things are negated like this, and you have an and here, one way you could do it is you bring them both together. So it's kind of like factoring if you think about it like math. And then this operator switches to an or. So I would have the same conditions, and this has been rewritten now using DeMorgans Law. So one thing you should notice is not y greater than or equal to 7. That's the same thing as y less than 7. So I could rewrite this instead of having not y greater than or equal to 7. It could say y is less than 7. So you may not always explicitly see that negation sign. You may just have to look at the operator and think, what would be the negation of x less than 5? If you're not less than 5, you must be greater than or equal to 5. So it's still possible without the signs there. So anyways, trying to recognize it again, there's the not. It's sort of like we're factoring it out. The operator will flip, and then I'm going to rewrite the 2 in here. So again, if I'm not equals, I could have just rewritten it with the not equals operator. So it may not be explicit when you see it if you're trying to rewrite something with DeMorgans Law. Here, it's in its sort of factored form if we're thinking about it from math. So I'm going to end up distributing that negation sign to both of those conditions. Then I'm going to flip my operator, and I'm going to put the same two conditions in. Okay, and then the same thing would apply here. I'm going to expand, and then I will just flip my operator and then put the same two conditions down. Oops. There. So now that we're using compound statements, there's something you should know about, and it's very, very handy. So You have to remember the way that Java does a condition, because you can manipulate this in your favor, and there are times when it's necessary to do so, or you wouldn't be able to run your program. So if we look at the AND statement, the only way that it's true is when both of them are true. As soon as I know one statement is false, there's no need to continue evaluating. It's going to end up being false. Similarly for OR, I only need one thing to be true. As soon as I know one value is true, I don't have to evaluate the other statements. I know the whole thing is going to be true. And that's the way that Java works as well. So we call this short-circuit evaluation, because when Java does an AND statement, it's only going to do AND as long as it's not false. So if I evaluated this first statement and it became false, and anything else, it wouldn't matter what else I had. I would simply just stop evaluating and know the whole thing was going to be false. So the only time I'll go through all these statements is when they keep evaluating to true. So it is an efficiency thing, but it's also something you'll notice at some point in programming. You will come across it where you'll have to do something that requires short-circuit evaluation. Same thing with OR. As soon as I hit a true statement here, then I don't evaluate anything else. I just true, or whatever else I have is going to be a true statement, so there's no point in continuing. I stop as soon as I know that this is true. So here's what it would look like for Java. True or anything else, you end up with a true statement. False and anything else would be false. So here's an example of where short-circuit evaluation actually can help a programmer. So if 100 divided by a number is less than 10, well, you want to check and make sure before you do this that it's not equal to 0. So if the number is not equal to 0 and that condition happens, because I'm using AND, the only way it will get to trying this is if the number does not equal 0. If this was false and the number equaled 0, it immediately stops that condition, so there's no way to divide by 0. So there are times when short-circuit evaluation can be manipulated in your favor. So aside from compound statements, we can also do nested statements. So a nested statement is when you put a decision within a decision, and that's perfectly fine too. Sometimes it's easier to read your code this way. There may be a specific reason why you decide to do it. The program flow, the logic of it, maybe it makes more sense to nest it. So when you have something that's chained together with AND operators, that could be equivalent to nesting them. So for example, if the gender is a male, and the only way I go on is when it's true. So I could replicate this by saying if it's a male, if that's true, it will go inside to this block. So everything in this block, I know that the gender is male now that I'm inside this block. So I can safely assume that this is a male teenager, for example, looking at this program. So one way we could work out what the actual minimum of 3 values is, we've done this with 2, is we could nest it. And we can make it a little competition. So I compare the first 2 values to see who wins. If value 1 is smaller, then I'm going to compare it with value 3. If value 1 is less than value 3, it's beat them all, so I know value 1 is the minimum. Now, if that didn't happen and value 1 is bigger than value 3, then I know that at this point, excuse me, that value 3 has beaten value 1, and value 3 also would have to beat value 2, because 3 would be less than 1, and I know that 1 is less than 2. So it would mean value 3 is the smallest of the whole group. And in this case, this is when value 2 has 1, and I'm comparing it exactly the same way. So I could nest it like this. I could also rewrite it with compound decisions, but when you write your programs, if you find it more convenient to nest, you can also do it this way.